Hi, this is COMP1010 at the University of Manitoba. I'm Dr. Celine Latulip, and today I'm going to be talking to you about copying arrays. So if we want to copy arrays, and we have two array variables like this example, where we have an int array, A1, and it is created through literal creation with the curly braces and 4 int values, and we have another int array reference variable, A2, we can use assignment to just copy A1 to A2. So if we try to do this, if we try to set A2 to be a copy of A1 using just a simple assignment statement, what we get is what's called a shallow copy, because all we're doing is copying the reference, which is basically the address that points at the array object on the heap. So what does this look like? Here we have A1, the reference variable for our int array, and it's pointing to an array that's on the heap. The array has 4 slots and the length is 4. And A2 at this point is, after this first statement, is just a reference variable. So it's got null in it, it's not pointing at anything. And then when we execute the statement A2 equals A1, what happens is A2 no longer holds null, it gets a copy of the address that's in A1 put into A2, so now both A1 and A2 are pointing at the same array on the heap. So this is what we call a shallow copy, and in some sense it's not really a copy at all, it's just two reference variables pointing to the same object. No new array object has been made here. So a shallow copy can be useful. It's often called an alias, and you have these two reference variables that are both pointing to the same object, and sometimes that's just what you want. So what's important to note is that if you make a change to that array using the A1 reference, the A2 reference is still pointing at that same array, and so that change will be reflected in anything you do with A2 as well. So if this is what you want to do, that's fine. But if what you really wanted was to make a copy of the array so that you could do something with the data and avoid destroying or doing something bad with the original data, then this is not what you want. In that case, you want a deep copy. And if you want a deep copy of an array, that takes 2 steps. You have to create a new separate array, instantiate a new array of the same size as the original, and then you actually have to go through and copy each array element one by one using a loop from the original array into the new array. So let's look at what that looks like. So here's the same exact 2 int arrays, A1 and A2. Again, A1 is instantiated using literals with these 4 int values, and A2 initially just has null in it. And then what we have to do a deep copy is we have to do an instantiation. So A2 equals a new int of A1.length. So here, this is the way we ensure that our new array has the same length as the old one. So we're using A1.length as to specify the number of elements we need. So A1.length will be 4, and so this will give us a new array also with 4 slots. And so that's what we have here. So now A2 is pointing at this brand new array on the heap that also has length 4, but in this case, these 4 slots at this point they're not empty because Java and processing will put in default values for primitives, so we have the default value of 0 in these 4 slots. Then we execute a loop. In this case, we're going to use a for loop because we're just counting through. We go from 0 up to A1.length, and of course this could also be A2.length. Both of them are 4, and we're incrementing by 1. And in this side of this loop, we're going through from 0 up to 4, and we are going into the index in the original one, so A1 of index 0, getting the value and copying it into A2 of index 0. So we get the 1, and then the next time through the loop, we'd copy the 9, the next time through the 23, etc. So that's a deep copy, and this way we now have 2 separate arrays. We can do something with this one, multiply all these values by something, or sort them, or what have you, search through them, do other things to this, and our original values can be untouched in the array A1. So deep copies can be really useful if you need to do manipulations and you also need to keep a copy of your original data. But it's important to note that deep copies are what we call an expensive operation. So they're expensive just in terms of creating the copy. So imagine if you have an array that has 200,000 items in it, That's a lot of copying. You have to loop through 200,000 times doing 200,000 separate operations to copy those items. So that can be expensive. But you also should note that you're now taking up twice as much memory as you would if you did a shallow copy, because now you've got two arrays with 200,000 items in it, so that's taking up significant amounts of memory. One other thing to note is that some programming languages have built-in functions that will create a deep copy for you. All you do is say something like arrays.copy and you give it the original and it gives you back a deep copy. And that's fine. You can also build your own function like that. What you need to understand is that even if you can call such a built-in function from a programming language and it looks like it's only one line of code because the loop is hidden off in that function, the computer still is having to do this expensive operation and you're still using up a lot of extra memory. So the message here is only create a deep copy if you really actually need to. So that's it for copying arrays. Thanks for watching.